Hey everyone, today we will be going over Learning Target 2, which, like Learning Target 1, relates to functions and graphs, but this time it is more specifically about the transformations and the combinations of functions. So, first we'll be doing a combination where we are asked to find f of g and g of g, which basically just means you're going to be putting a function inside of a function. So let's start off with our first one, where we are going to find f of g. So we can rewrite f of g kind of like we would for a function of x, where you can write f of g of x. And we'll be going from the inside out here. It's always important to remember. So we're going to be putting g into f. So simplifying this, we can write f of 1 minus 4x, which is g of x. So now we'll be looking at our function f of x, and wherever we have an x, we'll be plugging in this 1 minus 4x. And it'll be very important to use parentheses here when we are going to be multiplying by like a coefficient or some sort of exponent or square root. So we'll write this as 1 minus 4x cubed minus 2. Now, technically, this could be simplified a little bit more, but it's cubed, and that can be a pain sometimes to simplify. So we're not expecting you all to do that on these checkpoints. So that is our answer for the first part of A. Now we're going to look at g of g. Similarly, we can rewrite this as g of g of x. And it may be a little weird to think about putting a function inside of itself, but it'll be exactly the same as we did before, where we will have g of 1 minus 4x. And that basically means wherever we have an x in g of x, we're plugging in that 1 minus 4x. So we can rewrite this as 1 minus 4 times 1 minus 4x. And then this one, it'd be good to simplify a little bit more since the math is pretty straightforward. So we'll have 1 minus 4 plus 16x, and that just comes from distributing out this 4. So, and then cleaning this up even a little bit more, we have 16x minus 3, and that is our answer for part A. Now part B is kind of similar, but we're going to be going in reverse now. It gives us that final function, and we have to figure out the different components. So for this one, it'll be very important to go from inside out. If we have f of g of h, that's the same as f of g of h of x. So we'll be starting with h of x, then going into g, and then going into f. So looking at our function s of x, we have an eighth root. Inside of that is 2 plus the absolute value of x. So the function inside of that function will be our absolute value of x. That's like the innermost part. So we can write that h of x is equal to the absolute value of x. So now we need to move out again to g, which the next most innermost function is 2 plus the absolute value of x. But we've already defined that h of x as the absolute value of x. So we will just write g of x as 2 plus x, since x will end up being the absolute value of x, and we've already defined that. So then finally, we are going one more step out for the entire thing, which is an eighth root. And just like the last step, we will just write x for the inside. And it's always good to check a problem like this. Now that we have our components, we have f of g of h. So starting with the outside, we have the eighth root. then inside of that is g, which is 2 plus our each value, square root of x, and that matches, sorry, I said square root, I mean absolute value of x, That is equal to our s function, square root of, or eighth root of 2 plus the absolute value of x. Finally, we're looking at transformations of a graph, and this graph will be of the function y equals the square root of x, which is represented right here. So looking at this bottom left graph, we are going to be doing the transformation y equals the negative, or y equals the square root of negative x. So this negative is inside the function, which means we will end up reflecting it about the y-axis. So this basically just means you're going to be drawing it the exact same, but around the y-axis. Apologies for my artwork there. That's somewhat similar, but you get the general idea for that. Now this next one, it's a -2, but it's outside of that square root. So I'm thinking a vertical shift here. More specifically, 2 units down. And that's because of the -2. So we'll end up having the same exact curve, but starting 2 units down. So it'll look like this, because we're going to be starting at -2. So now we look at this last graph here, where it looks like we have 2 transformations. So an x plus 2 means we'll have a shift 2 units to the left. And also, we have this negative sign out in front, which means we'll have a reflection about the x-axis. So for a question like this, I like to start inside out. So first I will shift 2 units to the left, which is right here at x equals -2. And then I'm going to reflect it about the x-axis. So I'll be drawing it like so. Oh no, that did not mean that to happen. Like that. So worst comes to worst, if you're having a little bit of trouble recognizing which transformation is happening, you can always just plug in some values. That'll allow you to just plot a few points around like that. You'll get a general picture of what's happening, and then you'll be able to draw your line. That's perfectly fine. But for future use, it is good to really work on recognizing when it'll be a reflection about the y or x-axis, and whether you'll have like a vertical or a horizontal shift. So that's Learning Target 2. If you have any questions, feel free to stop by office hours and we'll help you out. And enjoy the rest of your day.